Vagnakat Sulan, set up in 2002 under the Extraordinary Gazette Notification of Government of Himachal Pradesh. This is the only private university in the state whose chancellor is the governor of Himachal Pradesh. With 108 professors, most of whom are PhD from reputed universities around the world, JUIT offers BTech, MTech, MSc, PhD in computer engineering, bioinformatics, biotechnology, and civil engineering, whose curriculum is supplemented by SWAYAM and PTEL. A home to almost 2,000 students, this university is twice accredited by NAAC. The world-class state-of-the-art infrastructure of JUIT has 57 labs, including Virtual Lab, eYentra Lab, IoT, lecture theaters, classrooms, tutorial rooms, laboratories, vast auditorium, administrative and faculty offices, an enormous library, and 6 well-equipped gyms. The campus is designed with a vision of creating a university of international repute and highest global standards. Fully equipped with learning tools and web-based educational environment, the campus is planned for the advanced computing infrastructure. Facilities like bank, temple, and helipad are all within the campus. JUIT takes pride in being a member to IEEE Chapter and Computer Society of India Chapter. It also conducts student exchange programs with the University of Nebraska, Omaha, and University of Florida, USA. To give an experience of the real corporate world and understand the challenges that lies ahead, our students also get an opportunity to connect with industry professionals and self-made entrepreneurs. Our exclusive placement cell has an excellent placement record. All this has brought us several accolades. We're ranked among the top 100 engineering institutes by NIRF, MHRD. We've been declared Best Private University of Himachal Pradesh by Dialogue India in 2018 for academics and infrastructure. We're also ranked first under category of value for money and third under the category of top private university in 2018 for offering value for money education by India Today. With a hygienic mess named Annapurna, well-furnished hostels with single and double rooms, mechanized laundry, 24/7 water supply, complete power backup, and Wi-Fi connectivity, we ensure that students feel at home while they're away from home. The overall growth in personality and confidence is taken care by conduct of debates, declamation contests, and a host of indoor and outdoor games. NCC Wing for Girls and a vibrant youth club that organizes popular sports festival called Padakram, literally festival and cultural festival, which further heightens their energy levels. They're also encouraged to develop independence in thought and action, as well as trained to deploy appropriate technology paradigms for given tasks, explore new horizons, and lead teams to solve complex problems. With our learner-centric educational process, students are free to find their own paths and learn their way to limitless opportunities that awaits them. So be a part of JP University of Information Technology, Vagnakat, Himachal Pradesh, to be the leaders in innovation, entrepreneurship, creativity, and management. Because this is where we engineer lifelong learners.
My job is to make college easier because
Okay, a very warm good morning to one and all present here today. I, Dr. Keethraj Singh, along with my team of Center of Excellence in Healthcare Technologies and Informatics, Department of Biotechnology and Bioinformatics, JP University of Information Technology, Vagnaghat, Solan, Himachal Pradesh, India. would like to welcome you all here on the fourth session of the season 2 of international webinar series that we are organizing since last year continuously. And today we are happy to have one of our very sincere and very tech savvy alumni, Mr. Satyam Kapoor, who is going to deliver some interesting topics today for us. The plan was that one student has to introduce him, but I think I cannot see that student. Janki, are you there? But if not, no problem, because he is one of my very sincere students, so even I can introduce him. But before that, I just want to tell you that you already have seen this video of JP University of Information Technology that was established in 2002 and is the only university, that is the private university in Himachal, where Chancellor is Governor of Himachal Pradesh. This Department of Biotechnology was established with the inception of university in 2002 only, and we started at that time BTech program in bioinformatics. So we are one of the oldest program in bioinformatics BTech in India. After that, in 2005, we started with BTech Biotechnology program. Then we started MTech Biotechnology. Now we have MSc in Microbiology, MSc in Biotechnology, MTech in Biotechnology, PhD in Biotechnology and Bioinformatics. And besides that, we have CSE, Electronics and Communication Engineering, Civil Engineering, Information Technology. These are other branches available with us. So before moving further, I just want to introduce you today's speaker, Mr. Satyam Kapoor, who is presently working with Sitecore in Belgium. He did his BTech in bioinformatics from JP University, and he was a student during 2012 to 16 batch. And I remember I was teaching him one subject like scripting languages for bioinformatics, where we were learning about the development of websites, databases. And he was doing lots of exercise at that time only, and he was implementing CSS and all those advanced techniques for the web content development. After that, completing from here BTech, he moved to Brussels, where he did Masters in Applied Computer Science from Vizej University, Brussels. After that, he worked as an IT domain as a software developer, making lots of APIs for REST. And then he moved to DevOps engineer position in life science and informatics in a software provider firm. And presently working as a cloud infrastructure engineer with Sitecore. He has lots of experience in recent technologies, and that's why he was planning to give some hands-on also. And I'm sure the content he's providing us today is very unique, because not so many people are working in this particular domain. But definitely, I'm sure we all will get benefited from his experience, from learning and the knowledge he contains regarding this particular field. So with this, I think I would like to call upon Satyam to move further to deliver his talk. Satyam, the dice is all yours now.
Thank you very much, sir, and thanks to everybody here. And the scripting language course was one of my favorite courses. I already want to say that, and that's how everything started. So let me try to share my screen, and we can go ahead. Let's share my full screen. Okay. Let me know when you can see my PowerPoint.
Yes, it's visible, Satyam.
Okay, my internet is a bit bad, so in case I don't hear you guys after some time, then I might keep on asking you that can you hear me or not. So let's start with the topic, which is containerization and DevOps for bioinformaticians. And I've tried to plan it in a way that we start with why containers, which will also explain what are containers, and then it will start with introduction to Docker, which is a tool to create containers, access them, and deploy them. Then we will do some small exercise using Docker, and then we will move towards just the DevOps philosophy, CI/CD pipelines, and we will use GitHub Actions, which is again one of the million ways to create a pipeline. And we will do a hands-on exercise on that. And we will, if time permits, we will talk more about some DevOps tools which I explore, and maybe we can have a nice discussion. So even though it's a webinar, we can always create it as a dialogue session, and you can stop me in between and we can have a discussion. So let's start with the basic question. So this is Mr. Sally Sood. He started learning Python and he wrote a fancy local alignment search tool, not the Blast one, but a Fast one. But the problem was that it was on Python too. Now this is Miss Pooja Shetty, and she is also a Pythonista, and she wants to use this tool Fast. But most of the operating system come with Python 3 pre-installed, and the persons who have worked with Python totally understand how difficult it is to run programs which are written in Python 2 with a system having Python 3. So where does Pooja Shetty end? Pooja Shetty ends up in a dependency hell. And that's not just a case with Python, that's a case with a lot of tools. That you've got a tool which is written with certain dependencies, and then you publish that tool on GitHub or anywhere, and then other people want to use that tool, but it takes a lot of time, sometimes even days, to install and get that working on your system. That's where containers come into play to help us to make things portable. So talking about containers, and I'm going to start from scratch. Maybe there are people who already know about this, so they can help me, correct me, or even improve me if I'm saying something wrong. Otherwise, let's start with what containers are. Since our university is located in Himachal Pradesh, and usually the seaside is so far away, so we don't see containers, but I'm sure we have seen that in movies or sometimes in real life. The containers are of standard shape, and they are size, and they have a locking mechanism, and they are moved by cranes, ships, trucks, and the people who are moving the containers, they just interact with the container itself. They don't care what's inside. Maybe it's a car, maybe it's some raw materials for a factory or anything. We just don't care. We care about the shape of the container, and that's what helps us to transport things so quickly using containers. Otherwise, it would be so hard. Imagine if there is different type of boxes which you have to transfer, and then you need specific type of machinery to transfer them. That's how containers started working in shipping industry, and they are still there. And the idea of containers into software engineering came a bit from the similar thing. So the separation of concerns allows for automation, which leads to higher reliability and lower cost. Because no, we know this is the standard. So if you're going to get something, 10 containers, okay, we can do that. So, but why containers in computing? So the problem is that there are a lot of languages nowadays. When I was studying, we used to work mostly with Perl, PHP. We also had classes with C++. But with every year passing by, there are more and more languages coming up. And the containers or the boxes which are present, not the containers, sorry, the boxes which are present are specific to a language. Let's say if you're building up a jar, that can only have Java application files, right? If you've got .deb files, they are just for the Debian version of Ubuntu. So that's why there is a need to create a common interface where applications from different languages can be deployed, and that's how containers come into play. So a container is a standard unit of software that packages up code and all its dependencies so the application runs quickly and reliably from one computing environment to another. So if I go back here, before, if Sally Sood would have deployed its application, which is based on Python 2, in a container and put it at a common place, let's say a repository, then Pooja Shetty would have just pulled that container into her machine, be it a Windows or Linux or a Mac, and just executed that, and it would be so easy to do things. That's where we are going forward. Now, now the term comes Docker. It's a very popular term, and it's the thing actually which made containers popular. Containers were existing from 20 years in Linux, but Docker is a company which came up, and then it helped develop more user-friendly software so we can start using container in our daily lives. So trying to read it from the slide here, Docker is an open platform for developing, shipping, and running applications. And Docker enables us to separate our application from our infrastructure so we can deliver software quickly. So let's say that we are still working with that application Blast from Sally Sood. So if Sally had to do something, how would he go? He would just create a Docker file, let's say a plain text file, and actually try to create something called as a Docker image. Once that image is present, then that image can be given to anybody, which can be to Ms. Shetty, and they can start up a container in their own machine. It will become more clear as we move forward. So just to go into the main terminologies, there's a lot of terminologies, and I invite you to go to the website of Docker. And I actually will feel very happy that if you will learn something from this presentation and go and visit that website, because the documentation is written so nicely. But let's focus on some of the key technologies or terminologies. So image, which I was talking about here, the image. So an image is pushed to a repository and then pulled to a host. Host means our computer, and then the image gets executed and a container is started. But what is an image? An image is a read-only template with instructions for creating a Docker container. So in this case, let's say Sally Sood wants to write a program in Python 2, then this image would contain instructions that, okay, I need, let's say, a base image called Ubuntu. I need Python 2 over that installed, and over that, I need my program, which, let's say, untitled.py to run. Once this image is present, then again, Ms. Shetty can pull that image and execute it. And when the image is pulled and executed, that stuff is called a container, which is a runnable instance of an image. So, and the most positive thing which I loved the first time when I remember getting acquainted with containers and Docker was that we can have multiple applications running on our system. So let's say again the Blastp application, we want more than one copy of an application, one to just test with some things and another to test with another thing. Let's say we are doing an alignment and we want to do it using multiple copies of application. Then we can run multiple containers. Let's say app A, B, C, D, anything on our machine. So we can have multiple instances of the same application running, which are totally separate from each other. I have to go to Docker hands-on now. So to take an example, let's go with the first thing. Blast is a tool which we study, I guess, in the first semester, and we mostly download that tool on our local system and try to run it. There is also a web interface of NCBI, but I remember that we also had an exercise that we have to download the CLI and install it. So imagine I have to run Blast on my system, and just the administrator hasn't given me permissions and they have not installed. So I already saw Miss Somlata here, and she already understands this pain. We had a lot of times that we want to install some things, and then we have to take her help, and she had to put in our admin password and stuff. But if we have access to Docker, then at least we will not trouble her anymore. So let's take an example in a practical way. So I'm going to just open my Sublime Text, because just so that I don't slow you guys, I created the commands here and kept it. So I have Docker installed on my system. It's a software. You can just go to Docker's website, download it, and install. You see there's this fish type of an icon, which is having a lot of containers. How do I check that Docker is working on my system? Let me clear. I hope you're able to see my terminal now. I just do a Docker ps. So like in Linux, there's a command called ls for list. In Docker, there's a command called Docker ps. Now you see there's a container ID image command, but everything is empty here. So there's no container running at the moment. Now, if I run this command, again, running Blast, I'll just paste it up here. I will say Docker run. This is the name of the image, which somebody has published, which contains Blast. It's evident from the name. Once this image is going to be running, then I say that I want to run Blastp and just want to go with help. So let's see what happens when we execute this command. And you see it showed us the help menu of the Blastp. It's a big one. I should have taken not Blastp, something else. But so we don't have, I don't have Blast installed on my system, but I just downloaded an image, which was a container. And I could run all those commands, which I would have if I would have installed the application on my system. If I try to run, just to show that I'm not lying. So I'm going to run Blastp, and you see the command not found. So going with the practical example and making it more interesting, let's say that we are molecular biologists studying prion proteins, and we want to find out if the zebrafish, fish is a model organism, has a prion protein similar to the human form or not. So how would we achieve that? There are multiple ways to achieve that, and we will take the protein sequence for two organisms and then try to compare them. But how can we fasten this thing up using Docker? So let's quickly go to this. So the first thing is that we have to download the human prion sequence from Uniprot, which will be the query sequence for us. I think I did download that and I didn't delete that. So I will just quickly verify if I have it here. Yes, so I do have this sequence P04156.FASTA on my system here. The next thing is download the zebrafish DB, which I have also downloaded here and named protein.faa. And now the next step would be prepare the DB using make Blastp tool for searching. Now this is from where we start running things. And I don't have make Blastp installed on my system. But because we can use Docker containers to run things without installing on our system, it makes our tasks so easier. So let me try to pick this command. We will go very slow and we will try to understand each and every statement in this command. So Docker run just states that you want to run a container or you want to take an image and then run an instance of it, which is a container. Now, what does this very ugly hyphen V sign does? So let's say if you're running a container, the container will have its own file system. It will create it when the container is made, and it will be destroyed when the container is destroyed. But we want the results to remain. We want them to persist. So that's why Docker gives us an option that we can create volumes. So this is a standard Linux command called print working directory. So this is going to tell the path where I am right now. And then it says create a folder named host-data. And in the container itself, when the container will start, mount that path to /data. Once that's done, then take the image again of biocontainers blast, and then run the command make blastdb, put the input, the file as protein.faa, which is the protein of that organism, which we are taking, the model organism, and then convert it to a db type of prot. So let's see what happens once we run this command. Okay, it was super quick because I guess I had executed the command previously because I was preparing these commands for you guys. Otherwise, it might take a while. It will download some files, which should take 30 to 50 seconds, depending upon your internet speed. So we see the output, building a new DB. It said the new DB name is /data/protein. So you remember we created this /data as a thing in the container. And then the title is protein.faa sequence. So let's do an ls and see what do we have. Oh, we have a host data directory, which we asked to create. Let's go inside the host data and see what do we have. Oops, we don't have anything. I was expecting it to create a database. I know what went wrong. We should have given the input file, which was protein.faa in that path. So give me a minute. Apologies for the same. What I will do is I will just copy these two files, which is protein.faa in host data, and also I will copy this because the next step would ask us to move this to this file. So now we have these two files in host data, which is mounted at /data in the container. Let's try to run the same command again. Being lazy, I will just type on the upper arrow, and yes, we've got this. I'm going to run it again. Okay. This time it's taking time, so maybe it's processing something. Well, hope is never a strategy, but I'm going to wait. You guys are able to hear me, right? Just to verify that I'm not talking to the wall.
Yes,
Okay,
yes,
yes.
Satyam.
Perfect. Thank you, sir. So we go to host data, and we've got the database up and ready here. So that's great. So now we have the database in a prot format so that we can search things. Once that's done, the next step is to execute the blastp for the final alignments. So the blastp command is going to be running on the same path, mount path /host data, which is going to be data inside the container. Use the image and use blastp as again the tool. We will use the query sequence as our sequence of the human organism, which we did, and then we will take also the database which we created right now, protein.fa as input, and the output would be results. So let's try to quickly take this up and execute that up here. But I will go one step out and execute it here. Oh, not a good thing. I didn't copy it nicely. Could have made more blunder than real things. That's the problem with live demos. That's why people record things, I guess. Okay, so let's try to run this. And something is processing, didn't give any answer. Let's go to host data and look if there is a file. We have a result.txt file. Just so that it looks better, I will just open in a text editor for you guys. And here we go. So the Blastp ran. We gave it an input and output file. It also gave us the significant sequences around here without installing even a single software on our machine. It was so easy. Imagine if we had to install the software and they had a lot of version. Then we had a chance that we would go in a dependency hell. So let's get back to our presentation and move ahead. I have to do a full screen, otherwise Sir is going to kill me. So yes, now we move ahead with the next thing, which is DevOps philosophy. So what exactly is this term DevOps? Why are people talking about it? And what does this say? So 10 to 15 years back, there used to be an operations team, and then there used to be developers. Let's say we, as bioinformatic developers, write some code and then say that, okay, this is our database. It's in PHP with the MySQL backend, and then we give it to the team which is handling the servers and say that, okay, please deploy it and run it. And then the ops team would say that, okay, things don't work on the machine. But sometimes the bioinformaticians say that, okay, but they are working great on my machine. You can even have a look. So this was a big problem because once the code has been given to the ops people, they don't understand anything about our code because they didn't write it. That's why with 2015 and 2016 coming in, more and more developers started getting a more idea about ops. So more of doing the ops stuff themselves because it's our code and we understand it better. So let's do it. And the best part about this is that earlier ops was using a manual process. So let's say you've got to start a server. You install the operating system in the server. Then you make some clicks. You set up a reverse proxy and all those things. But software developers, be it bioinformaticians or computer science people, we are lazy. We don't want to do manual things. So we start automating things because we already know how to automate. So DevOps actually includes a cycle which starts from development of an application, then doing compliance, delivering of an application, then operation of an application. And of course, the first thing always starts with plan. So it means all of these things are being done by same type of people, which are developers. So more and more developers are actually learning about operations these days, and they're being following the DevOps philosophy. So DevOps engineer was a title which I was employed at in my last organization, but actually that title is vanishing up because it's not a title, it's a philosophy that you do your operations yourself. Going with the definition. So DevOps is a compound of development and operations. So DevOps is the union of people, processes, technology to continually provide value to customers. It's not like this is my job, this is your job, this is our job. Let's get stuff done. Next slide. One of the main things which gets associated with DevOps is CI/CD. And I don't know about other students, but most fourth-year students, or even if there are master students here, if they're going for interviews, if they see job description, this is a big thing which is being talked about. That do you know anything about CI/CD pipelines or some stuff? So let's dive in more. What does it mean? So it means continuous integration and continuous delivery. And it's a set of process that helps software developers teams deliver code changes more frequently and reliably. CI/CD is a part of DevOps, which helps shorten the software development lifecycle. So let's take an example. What used to happen 10 years back if you're developing a software? You develop the software, you put that in a disk, perhaps a DVD at that time, and then you give it to the people who are handling the servers, and you tell them that, okay, we want to deploy this thing. But it takes time, because first you are going to write it on a DVD, then you're going to hand them over, and then the person would say, okay, I will do that tomorrow, and things go bad. That's where CI/CD came, and it's a part of DevOps philosophy, which says let's move fast. That means the moment you say that my software is ready, it should be deployed and it should be live. And let's go a bit more deeper to understand what does CI/CD includes. Again, it starts with planning of your software. You start building this Blastp tool, which is a fictional tool. Then you start coding about it. And then let's say you are using a compile time language, you start building the tool. Once the tool is built, then you start testing it. Writing tests is very important. Once it has passed all the tests, then you go to the release. Let's say release version 1.0. Once a release is ready, it should really get deployed to production. Once it's deployed, then a user, let's say a user who wants to use the database, they can go to the website and they can just start using it. So this process, which is code, build, and test, this is called as continuous integration. And just to give you more idea why this term, sometimes it can be like it doesn't get into my head, why integration? It's because when we start developing software, it's not one person who's developing. Most big softwares include many people. So let's say even if it's a research software, there would be a collaboration between some people and they would write. So I wrote a method, and I wrote a method to do certain things. And as soon as I wrote a method, I pushed it to Git or version control. And as soon as I pushed it, it will start running some tests. So let's say Tirat sir and I are working together. I've never got this opportunity after university, but maybe after this, I'm able to convince them. And then he starts writing multiple methods. And then I say that, okay, I'm going to drop in, and I will also just chip in, and I will going to help expand the functionality of a specific thing. So I write another method, and as soon as I push the thing, the whole software breaks. And that's when sir comes and say that it was a bad idea. But if we are following with a DevOps mindset, we would have a CI/CD pipeline. As soon as I have that method ready, I'm going to push on Git. It will start running some tests which sir have written. And if I am doing dirty code, it will block me there saying that, okay, we cannot go ahead because the tests are not passing. That means I did something bad. Sir wouldn't even know. I would get an email, and then I will start again another night writing things nicely. Once it's done, the test is passed, release would be here. Once a release is here, it would be deployed. And sir would also get a message that, okay, a new code is deployed and it's a new version. You can just try and look at it. But there are less chances of things being messed up because we write tests and we do a CI/CD pipeline where an integration is done between what sir is doing and I am doing. Is it proper? Is my small snippet of code, can it be integrated with the bigger set of software, or it's going to mess it up? Once integration is done till the test phase, then it says, okay, let's deploy it. That's continuous delivery. Not like I'm going to write in a DVD and send it to somebody. I will say, okay, everything looks perfect and it should be deployed. The website is live. So there's a very nice tool which people have been contributing, and I invite you all also to contribute to that. That's Biocontainers. I think their website is biocontainers.pro. And what they do is all the tools which are for bioinformaticians, they take them and they convert them into containers and pipelines. And how their pipeline looks like, let's say this is a bioinformatician developer user. It creates a Docker file for a tool, something with which you can create Docker images. Once that's done, they push it to Git. Once they have pushed the thing to Git, it notifies another person that, okay, a new pull request is ready. In this case, this would be Tirat sir, because let's say he's handling the project. Once he has checked that, okay, everything looks good and things are not bad, he can accept the pull request. If things are not good, he would say, okay, this thing needs to be improved. The person who has submitted this thing would get back a feedback, and he will try to improve it and submit the thing again. Once sir is happy, he has said everything is good, then it will move to a CI/CD pipeline tool. Here, this is the logo of Jenkins, which is a popular tool in industry. But there's not one thing. There are many, and we will also explore one of the tools, which is called GitHub Actions in the next slide, I guess. So what does this tool does? It runs a script which says that if it's a Java program, I'm going to compile the Java program. And once it's compiled, I'm going to push it to the web server, which is a Java web server, and also push the latest container image to the container repository. Once this repository is here present, then anybody, we as a user, can pull in. So an example again, this was an image, biocontainers Blast 2.2.31. So if I would have pulled it yesterday, let's say, then maybe it was 2.2.30, but somebody actually pushed this thing and it got approved and the image was with the new version available on Docker containers. And I could pull the latest one here and run Blastp. So as a user, you don't even feel how fast the delivery is, and there are issues which are being solved. I don't even know, maybe if I do another instance of an of executing this application and say that the tag is not 2.2.31, I say that whatever is latest, it downloads 2.2.32. So this is all the fun of pipeline. Now, just to give an example of how this pipeline works, I'm sure there are a lot of things which are not clear, and I'm trying, or I will try my best to explain you in the questions. But first, let me show you a pipeline. I'm going to go back to my terminal. I guess you guys are able to see that. Okay, I should have a folder on IWS. It's here. So yes, so this is a Git repository. I also have that open here, and it contains a file called Docker file. So this is how you create those Docker images, those templates which anybody can pull up. Let's look at inside what it includes. It says from PHP 7.2 Apache. So it's taking a base image, so we can actually make images out of images and expand over them. So it says there's a image available for PHP and Apache 7.2. Take that and copy the index.php file, which is on my system here, and place it inside this image on var www.html index.php. Once that's done, please expose the port 80. And when everything is done, just run a Linux command, which will actually just start the Apache web server in foreground. So going back, I will actually open this in my text editor, so things look much better. Yeah. Yes, I trust the author. It's me. Okay, so this is a Docker file. You see, even Visual Studio Code is so nice that even it gives you the logos. So this is, everything is ready over here. This is going to create an image. Then the next thing is this file, which let's say I want to place it. This is my software. I mean, it's a dummy one, but it's just a one-page file. You see, very old style HTML things, JP University of IT, and there's some PHP function inside it here, and this thing currently is live on a URL, which is iws.satyamkapoor.com. So you see, doesn't look overly bad for the small script. Now, if I want to change anything here, then I will have to create again a Docker image, push it, and then wherever my web server is, which is a Linux server, I will have to go and pull this code there. But thanks to CI/CD and GitHub launching GitHub Actions, if you have seen this thing. So here I can write up a script which does certain things in a pipeline, and the configuration resides in this small GitHub Actions script. Let's try to quickly read it from up. So it says, okay, as soon as there's a push on the branch called main, start a Docker container with Ubuntu, set up some tools with QEMU and Docker Builder X, log into my Docker Hub account where the image will get stored. There's a username and password. Never store the username and password in plain text. So it gives you an option to set up some environment variables or secrets, and I'll show you later where they are. Then do a Docker build and push, and then SSH into my machine with this username, password, host, and this port. Once that's done, then just run this script. There's a container running there. Stop IWS container, remove the container, pull the latest images from this image, and then initialize the thing. So let me try to even show you what is running right now on the server. So let's try to do an SSH. Yes, now we are in the server, and I can run that command docker ps, which I showed you, to see what type of containers are running. It has a lot of stuff running, some of my personal stuff also, but this is the main thing. I am Satyam Kapoor, IWS latest, you see, 2 hours ago. So yes, I did prepare this also in the last hour, used to of JP University, but we can deliver things. So once this container is up, this is running, and it also says that the port 80 of the container is actually bound to port 9991 on this machine. So if I do a curl to localhost 9091, then we should, why? 9991, my typo, sorry. So you see the HTML is already here. Once this thing is up, then we are running an Apache in front of this, which is actually associated with this website, the domain, and it updates things. Just to show it in real action, what would we do is we would just try to change something. And I already left the small thing commented out, so it's going to just echo the date of today. So I'm just going to save this. Once this is saved, I'm going to open the terminal here. Yes. Okay, I do a git status. Is there something changed? Git says index.php changed, which is correct because we changed it ourselves. I'm going to add this file to git. It's added. Then I'm going to do a git commit, which will be a message. What changed, just so that people know. Added date function. Once this is done, I do a git push, and then all the magic is going to happen. Push happened. Let's go back to our repository and go to actions. You see, added date function is here. And it's going to run all those things which we saw in that .github configuration file. Okay, it's started up the job. It's downloading that SSH thing. Okay, setting up QEMU, which was also required. Once that's done, it's set Docker. Oh, that's running too fast, right? So let's try to close these so we can easily explore what's happening. Yes, so it created a Docker build, and then it published that. It logged into my Docker Hub account, which is the image repository where image is stored. Then it built and published, and then it went to my server and started deleting the thing and starting a new thing. So let's do a Docker PS again. Okay, or it's still running. It's still running. I was too fast. Sorry. Let's say yes. It says the job is completed. Now we do a Docker. I will clear it up actually, and we do a Docker PS again. And you see 14 seconds up. So it deleted the old one. It pulled the latest image, and the latest image should actually include this new change of index.php, which we added the date, and it published it. Now let's go back to our website and try to refresh. And here you see the change. Saturday has already been here. So this is continuous deployment. Whenever we do any type of a change, we push the change. I mean, of course, I fast forwarded it. Otherwise, I would send requests to Tirit sir saying that, do you accept this change? Once he says it's accepted, the software will be built and deployed continuously. So there are no DVDs waiting for people and stuff. And this actually fastens up the process. Now I will try to go back to my PowerPoint slide. And it's actually a similar step happening here, just a bit more lighter. And rather than this tool Jenkins, we are using something called Github Actions. And I really invite you to look over it because it's available for free. So it's a feature of GitHub. Automate your workflow from idea to production. They've explained it very nicely that how can you build, test, and publish things. Going back to my presentation, and okay. So now talking about more of the DevOps tools. So this was something which is a CI/CD pipeline. But at least bioinformaticians have faced this issue a lot, that you have workloads which want to run with maximum capacity, a lot of CPU requirements, resource hungry. Then what do? Then you start using public cloud these days with AWS, DigitalOcean, giving special discounts to academicians. That's a good thing. But the problem again comes that you go to AWS or DigitalOcean or Microsoft Azure, you do things with clicks, you start up a machine, you deploy things, and one day you're like, okay, things went wrong, we have to start up again. That's where Terraform comes in, and it's really being popular these days. So what it does is it does infrastructure provisioning through code. So you write some code, you say that, okay, I need a new virtual machine. Sorry about that train sound. I need a new virtual machine, which needs to have a RAM of 16 gigs, which needs to have an SSD of 250 gigs. Just get it up in the Mumbai region, and then you can start working on stuff. And since it's in code, tomorrow, if somebody else wants to do this, you can also share them the code. See, I wrote this code, and you can get this machine up ASAP. And that's how infrastructure is being provisioned. And that's one of the major part of my current job. that I write code to make sure that infrastructure is up quickly and we can destroy it when we are not using. So let's say you ran a job which did some process of bioinformatics, and after some time, once the job is finished, you want that the infrastructure should be destroyed because we are paying for it. It's public cloud. Then you can do that with Terraform. Similar tool is Ansible, but it's for configuration management. So let's say we have 5 servers in our bioinformatics lab, and we want that on all the 5 servers, a specific software, again, Blast, needs to be installed. Ideally, Docker is going to be the best thing. We should not install that. But let's say there are some administrative things that we really have to install. Then with Ansible, you can write it in one script that, okay, install this thing on these 5 machines, and it will do that parallelly. So people who are installing things one by one, it will at least help them to do things. And that's where I end the thing, but I'm sure, or I hope that there are questions, so we can go more deeper back. I'm going to go back to my browser and I will not stop presenting, or maybe I will, yes. So was it too fast?
No, it's okay. Let's see if we can have some queries from the participants. Please write your queries in the chat box, or you can ask even live queries to a very tech-oriented person. I know it was little more technical for some of you, but still, because I am teaching HTML, DHTML, web development, and so many other programming languages, and many of you are already aware of all these things. So they should have enjoyed this session, because first time I saw this kind of demonstration regarding Docker and how the things are being technically made or deployed in live basis. Okay, so Satyam, Ali Ayub is raising hand. Ali Ayub, you can ask the query if you want to ask.
Yeah, maybe your mic is muted, Ali. Or maybe you want to type in. We cannot hear you.
Maybe you can type in the chat box, Mr. Ali
Yeah.
Ayub.
Is something being typed? Nope.
Okay, anybody else asking for any query, especially the BTech students?
Okay, I see a thing from Mr. Rohit Shukla.
Yeah, one query from Rohit Shukla.
We're writing script using Python and it needs sklearn and TensorFlow. So can we make a container and user will not need to install this? Absolutely. I am actually super sure that there is a container already available. An image, Docker image already available with TensorFlow and sklearn. So you can really use it to even do your personal development. You don't even need to install that on your system. So it can become very easy. No problem.
Okay, Satyam, I just want to ask you, like, as you told that whenever you are trying to make modifications, then you have to redo that process in the background.
Mm-hmm.
And maybe the administrator is asking for those changes, and you have to ask the administrator to make it through or not.
Yeah.
So every time we need to replace the older file, or we can have some option like we can create another folder or another container just to keep the backup of older things in parallel to the live programming.
Sure, sir. For the backup thing, there are multiple strategies, and I think again it goes to there is no limit of our imagination, and we can go with that. But an example which comes is, let's say that it's a Java application going with the compiled language, and you wrote some program, it got compiled, and a jar was created. Now that jar can be pushed to a repository. And whenever a new change is there, then a new jar can be pushed. So we always have a backup of the older jar. Plus, sir, the positive effect of using Git, which is a version control in our life cycle, is that suppose that this date thing which you told me it didn't, which I showed you actually, it didn't work out, then I can just go back with the Git command and push an older file commit to the main branch. Once it will be pushed, the changes will be reverted back. So we always have the history. I remember when I used to work again in scripting languages, started with HTML and CSS, I used to create multiple folders. This is main 1, main 2, main 3. And at last, it used to be very confusing. So Git has helped us solve that problem. So it's like version control system, and you can always come back at any point. All the history is retained.
Okay. Okay, for the participants, I just pasted the link for the feedback form. You can please fill it up to get your certificate. But in between, we have few more queries. So let's go first with Ajay Sharma is asking, thanks for the presentation. My question, what will be the minimum requirement to run Docker? The first question. And the next, second question is asking, if can we use GitHub to host our live working project?
Okay, so the first one from Mr. Ajay Sharma, it's really a lightweight thing. It's not a heavy thing. And if you I even have a Raspberry Pi at home, which is a 3,000 rupees computer, and it can host Docker. But the problem comes in that, let's say you want to compile something which requires a lot of memory. Then for compilation in Docker, it will use your host machine's memory, right? So you can have Docker on your machine with even the minimal memory. But if you need 16 gigs of RAM to do your task and your host machine does not have that, then it will crash. So to start up, it's not a problem. So running this PHP image, which was a basic web server, it can be even done, I think, within 100 MB. So it's not a problem. Another thing is Mr. Santosh Patra. How one can link AI and ML in bioinformatics? No, I got confused. Was it this one, or I will go with?
Yeah, this was the one from Santosh Patra. He's just asking a general query like how one can link AI and machine learning in bioinformatics.
Well, I think there are more educated people sitting here which will answer that rather than me. So I'm sorry, but I'm not that. I mean,
Santosh, these domains are really growing very well, and artificial intelligence or machine learning, it has application in bioinformatics, not from now only. It has from last like 2-3 decades. When bioinformatics was growing, in parallel, the computational technologies were also growing, and machine learning was the major boost up to the data science or data analysis. Nowadays, we are talking about the data, but later on, artificial intelligence was also involved in that. And nowadays, we are looking for the driverless car. That is an application of AI and machine learning. But in bioinformatics, also lots of applications from AI and machine learning are already there. But this particular session, as you know, we were talking about the Docker and all those Devops tools and biocontainers. But still, those are having some background related to AI and machine learning also. So you can explore more about it, definitely.
Definitely. I mean, I think one thing which I would again like to highlight, and I've already talked with Tirat sir a lot, that whatever is happening in computer science is possible in bioinformatics. Actually, bioinformatics is a subset of computer science. And while I was doing my bachelor's, I was we are naive and we don't understand that much. But later, when I went for master's, which was in applied computer science, I even had bioinformatics subjects in there. So the positive point of doing bioinformatics with respect to computer science was that we were even learning biological information. We had exactly similar courses, except a few which were like compiler design or something. But for me, I had even a machine learning course. So, I mean, you cannot separate those things. So if AI/ML is being used in computer science, then definitely it can be used with bioinformatics. But like Sir said, actually it started with bioinformatics first. It was the opposite thing. Yeah. I can even see Rahul sir here, and I remember he was the placement coordinator at the time when I was in fourth year, and it was difficult to convince some people during placement times that the bioinformatics people also use the same tools and they should be allowed to sit in those placements where computer science people are being seated. But that's a different story. But anyhow,
yeah.
So
Rahul, are you available? Okay, in the meantime, Satyam,
yes.
we have two questions. One is our own BTech students, maybe your junior Janki. She's asking, where do we begin learning Docker? She's doing BTech in biotechnology, but she has taken bioinformatics as minor.
The best website to learn Docker is Docker's own documentation website. It's the easiest. Like with HTML, we used to start with W3 schools at that time. I don't know what we do now. But with Docker, its own documentation website is so crisp that it has some quick start tutorials. So if you don't want to dive in the major things, and then it goes with the advanced things. So you can always start with that thing. If you don't want to go with that, there's an author called Nigel Poulton, and he writes very nice books in very, very basic English, which I find it very nice. And I learned a lot of stuff from there. So you can always refer to that book. I will even try to put the link in the chat here if it's possible about that book. But yeah, okay, that's one thing. Another question was there, sir, about what we can host on GitHub. So on GitHub, we can host any static website. So HTML, CSS, JavaScript, anything for free. And so if you're paying for hosting your projects on a server and you don't want that much control, you just have static files, then you can always host it on GitHub. And the thing is called GitHub Pages. But if you want to go with dynamic things again, then you need a web server, right?
Okay. Yeah. Satyam, there is one more query from Pranav G. She asking like, can you comment on scalability and development of web apps using Docker?
Oh, this is okay. This is
Very
so
interesting question.
very
Yeah.
overly interesting question, and I mean, so let's say that you have a web server and there are 100 people who are using it. It's in a development stage, and suddenly you put up a paper which got super popular, and there are more than 1 million going up. What would you do? You would like to run multiple Docker containers and put a load balancer in front of it, and that's where tools like Kubernetes come into play. So Kubernetes is another tool which does orchestration of containers. I'm sorry for this phone. I hope somebody will come up and pick it up. Just give me a minute. Yes, somebody came. They are running ASAP, please. Done. Okay. Yes. So let's say how Google runs services, and there is a very nice book on that. It's called Site Reliability Engineering. Like Google Maps, there are a lot of people who are using Google Maps every day, and they cannot start up a new machine every time. So what do they do? They have a collection of servers, which they call a cluster of, let's say, 100, and then they start running all these maps application in containers. How do they manage so many containers? They use a tool called Kubernetes, which they designed themselves, which orchestrates these containers. So scalability can be achieved with containers, and that's one of the basic advantage of containers. I mean, I was trying to convince you that you don't need to install applications. That's also an advantage, but scalability is a very big advantage.
Okay, Satyam, just want to update you that total attendance I got today was 71 unique names, those who
Okay.
entered the session. So total 71 people listened to you carefully, and there were times when more than 40 were there always in parallel. And I am happy that many of have learned about this very new technology, because so many are not even aware of these names. But still, I hope some of our students, so many people from other institutions will also try to learn these technologies, and they will be good in these kind of recent technologies for the development of biocontainers specifically.
Yeah. If you are putting that in your CV and you understand that term in third year, then I can guarantee you that you will get placed in a very nice company.
Yeah, definitely. You can get a very good package, because now this is in demand all over the world.
Yeah.
And IT-oriented companies who are developing the bio-based contents, they are looking for such people who can do work on biocontainers and development of containers.
Yeah, even this biocontainers website. So when I was trying to get these Blast and those containers, people have even written a lot of research papers about it. So this biocontainer website, if you understand how these containers work, you can even help them and contribute in an open source way that, okay, this is my tool. I want to even if any professor, let's say, wants to publish their own tool, it's best that you even create a Docker image and publish it and put it in biocontainers. That's also an advantage.
Yeah. So I think there is no further query from the participants. I already pasted the feedback form. Please fill that to get your beautiful certificate. And I just want to tell you that we will be continue with this series still. At least 1 or 2 webinars are still pending. Hope we will be doing in the coming months. And I'm thankful to each and everyone who present here today. And on behalf of the Center of Excellence of Healthcare Technology and Informatics, Department of Biotechnology and Bioinformatics, JP University, I would like to thank each one of you listening patiently to Satyam Kapoor and all of us. And the special thank goes to Satyam for sparing time and teaching us some new and interesting things in the upcoming technology field. So thank you everyone, and I hope you enjoyed the webinar. Soon we are going to provide you the link on YouTube. It will be available on YouTube also, so you all can enjoy over there. And if still you have any queries, you can just connect to Satyam also, or you can call me also. He is available at satyamkapoor.com, always with you. Okay. So thank you, everyone. Thank you, Satyam.
Thank you,
Thank
sir.
you, one and all present here.
Thank you.